important theorem. The first one is argument principle. Now, what is argument principle? Many of the time there is always a question on argument principle in the entrance exam, if you say in the gate exam, and there is always a question of that. So let C denote a positively oriented simple closed contour and suppose that first thing, a function f of z is meromorphic in the domain interior to C. Do you know what is meromorphic? I think in last class I told you. What do you mean by a meromorphic function? Yes, a meromorphic function is a function which is analytic throughout D except for the poles. Throughout your domain it is analytic except for the poles. Or you can say a function which can be written as quotient of two function, that is p of z, and quotient of two entire function, that is called a meromorphic function. So a function f of z is meromorphic, and the next is domain. F of z is analytic and non-zero on C, and third is counting multiplicities z is the number of zeros and p is number of poles of f of z inside C. Then integral f dash of z upon f of z over that contour C, that is equal to 2 pi I z minus p. You see, if you see a question that where integral is ऊपर डेरिवेटिव है, नीचे ये फंक्शन है, सो इसका आंसर आएगा 2 pi I just z minus p. For your function f of z, you just need to calculate what is your what is the number of zeros counting multiplicities. That is, if 2 is repeating 3 times, then it will be counted as 3 dots or 3 zeros. If you say, if pole is repeating, then you have to count that also. So to do any integration of this form, you have to do this. There was a question. Let me just give you quickly an example. For the latest exam, I think 2021 में ये question आया है. The question was e raised to z upon e raised to z plus 1, ऐसा कुछ था, plus 1 or minus 1. This was something, and you can give any domain, say mod z less than 4. Suppose you are telling this as a domain, correct? What do you see? If you want to solve this integration, can I apply my Cauchy integral formula here? Can I apply Cauchy integral formula? No, because for Cauchy integral formula, in the denominator, that is whatever the pole is, I need to have that in this form, z minus something raised to n, and I won't able to write this thing in that form. Do you see? First of all, what are the poles of this? E raised to z plus 1. What are the poles? So you need to put e raised to z plus 1 equal to 0, correct? So that means e raised to z is minus 1. So what are the values for e raised to z minus 1? Minus 1 कब आता है? e raised to I pi, I think, ना? Plus 2n pi I. So what is the value of z? So value of z is I pi, or I common लिया, pi plus 2n pi I. Correct? So this is the value of z. So you draw this thing and try to see. Now do you see this is of the form f of z and f dash of z. Do you see? This is e raised to z plus 1 and its derivative is e raised to z. So all I have to do is look at this function f of z. What is f of z? Is e raised to z plus 1. So you need to find the roots of this, number of roots and number of zeros. Sorry, zeros is same as roots. Number of zeros you will have to find, and number of poles. Here you see that there is no poles. This is analytic function. This is there. In this case, there is no pole for this function, so this is 0. Pole is 0. You have to calculate number of zeros, all the zeros which lie in the contour, in the domain. Suppose in our case, suppose it is phi. Then your answer will be 2 pi I into z minus p, phi minus 0. So answer will be 10 pi I. That's it. Is that clear? So this is how you should think whenever you see function the f dash upon f. Then in the domain you need to find number of zeros. Number of zeros and number of poles of the function. The function is this. Find number of zeros. This may be. I'm not going in detail. You just go do that. Check which of the poles, which of the zeros lie inside the pole. There are infinitely many zeros, but I need everybody, those who are lying in the domain. So I have to consider those only. So that will be zeros and poles. Just you put in the formula. What is this? Integral of this equal to 2 pi into z minus p. That's it, done. Okay. And one more next most important theorem, that is called Roche's theorem. Roche's theorem. Okay, so let us write the statement. Let C denote a simple closed contour and suppose that first thing is two functions f of z and g of z are analytic inside and on C. Okay, the second thing, suppose you are given a mod f of z that is greater than mod g of z at each point on C. At each point on C. Okay, then f of z and f of z plus g of z have same number of zeros, counting multiply cities inside C. Okay, now what is the benefit of this theorem? Let us see one example. Suppose in some question they are asking you find the number of roots of the function, say of the equation, say z raised to 7 minus 4z cube plus z minus 1 equal to 0 inside mod z equal to 1. Then how will you write this? How will you solve this? Look at the question. Can you do it directly, or do you have any trick to do? See, this is degree 7, this is not degree 2. You cannot directly do that, this question. Yes, can you do that? Do you have any technique? How will you do? Find the number of roots of the equation z raised to 7. So you have to get all the roots which are only inside this mod z is equal to 1. So that is a very nice problem if you see, and it is very lengthy if you want to do that. So it is easy for us in this case if I use Roche's theorem. So what Roche's theorem says, it says let C be a simply closed contour, and suppose that two function f of z and g of z are analytic inside and on C, and you are also given mod f of z is greater than mod g of z at each point on C, then f of z and f of z plus g of z have the same number of zeros. So what we have to do, whatever we are your question is this one. I need to get a f of z such that this should be satisfying. Mod f of z should be greater than equal to mod g of z. So that means this function I need to break it into two functions. Whatever the question given, I have to break this guy into two functions, f of z and g of z, such that, can you give me a f of z here and g of z, such that mod of f of z that is greater than mod g of z. Of course, where we are talking inside mod z equal to 1. Can you give me? See, mod z equal to 1. So if you see this one, if I am taking f of z as minus 4z cube, and g of z I am taking at other thing, z raised to 7 plus z minus 1. Do you see this condition is satisfied now? Do you see that? What will be your mod g of z? Mod g of z is this one, that is mod of z raised to 7 plus z minus 1. If you use triangle inequality, this is equal to mod z raised to 7 plus mod z plus 1, so that is less than equal to 3, which is definitely less than this guy. Do you agree? Because what do you know about f of z? This is minus 4z cube, correct? Which is definitely less than mod of minus 4z cube, which is 4. Mod of this is 4, correct? Because mod z is less than, mod z equal to 1. So which is less than mod g of z, mod f of z. Do you see the conditions are satisfied of the Roche's theorem? What you have to do, whenever you are given with an equation in the domain, you have to break this into two functions f and g, such that mod f of z must be greater than mod g of z. You have to decide. So clearly मैंने क्या किया, इसमें देखा coefficient mod z equal to 1 था, तो I saw the coefficient here, the coefficient was 4. So it is better to take this guy here and take that other people aside. Do you see all the condition of Roche's theorem is satisfied now? And what do you know, how many zeros are there f of z has? How many zeros? F of z is minus 4z cube. That means 0 is a root and it has 3 multiplicities inside the circle mod z equal to 1. You write it by Roche's theorem. f of z and f of z plus g of z will have same number of zeros, will have same number of zeros. Correct? What do you mean by that? What is your f of z? F of z is this, minus 4z cube. That means 0 is root of f of z with 3 multiplicity. That means number of zeros of f of z is 3. Of course, with multiplicities we are taking. So, number of zeros of your function f of z plus g of z is again 3. What is that is? f of z plus g of z क्या है तुम्हारा क्वेश्चन जो भी है? z raised to 7 minus 4z cube plus z minus 1 in mod z equal to 1 in this domain. You see, we got the answer. So the question was quite difficult, that you have to first of all, to get the roots which are inside this, you have to find all the roots. That is the first thing you should do. If you got all the roots, then the next thing will be decide which of the roots lie inside that. Correct? Let us ask one more question related to this, the same question. Determine the number of zeros. Say the question is this: 2z raised to 4 minus 2z cube plus 2z square minus 2z plus 9. Determine number of zeros of the function. This is 0. Determine number of zeros with multiplicity. Can you give me f and g? Can you give me f of z and g of z such that mod f of z and contour is in mod z equal to 1 again. Mod f of z is greater than equal to mod g of z. Can you give me two function? Anyone? Can you give me f of z and g of z such that mod f of z that is greater than equal to mod g of z? Actually, it is not greater than equal to, I'm sorry. Should be strictly greater than. Do you see anything? See, mod z equal to 1, तो मैंने पहले ही ट्रिक बताया तुमको, mod z equal to 1. So try to see the coefficient. यहाँ पे this will work as 1, this will work as 1, this will. So if you add all these things together, then also it is giving you 8. 2 plus 2 plus 2 plus 2. It is giving 8, and I am having one guy who is 9. So it is better to take f of z is equal to 9 and g of z equal to other people's. Is that okay? Do you see that? क्या किया मैंने? Do you see it is satisfying? Because if you take mod g of z, what is mod g of z? That is mod of 2z raised to 4 minus 2z cube plus 2z square minus 2z. And if you apply this, you will be getting 2 plus 2 plus 2 plus 2. That is, which is same as 8, which is less than 9. And what is 9? It is mod of f of z. So you are having mod g of z that is less than mod f of z. So what do you say? By Roche's theorem, can I say something? The number of zeros f has, the number of zero f plus z will have. But how many zeros are there of the function f of z? Yes, number of zeros of f of z is 0. There is no 0 of this function. There is no term of z. It is non-zero. You see, it is never 0. So number of zeros कितने हैं? कुछ भी नहीं है, 0 है. Hence number of zeros of the function f of z plus g of z, that will be also 0 with multiplicity. Is that clear? One question for you guys. Determine for this. Say yes. Z raised to 4 plus 3z cube. ये थोड़ा सा डिफिकल्ट करता हूँ. Z raised to 5 plus 3z cube plus z square plus 1. Inside mod z equal to 2. Number of zeros बोलो क्या आएगा? Can you do that? Can you give me two function f of z and g of z such that mod f of z is greater than mod g of z? Can somebody give me? Yes. mod z equal to 2 बोला है. Correct. So you should do one thing. mod z की जगह z की जगह पे 2 पुट करने का and get the values. ये अगर 2 raised to 5 कितना होता है? 32 ना. So this is giving me 32. This is giving me कितना आएगा? 24. This is giving me 4 and 1. What should I choose my function f of z? This is quite clear from here. Yes, anyone? This is 32, this is 24, 4. If I add all these things, again I am always less than this 32. So, of course, I should say check f of z equal to z raised to 5, substitute karo, and g of z must be other people. 3z cube plus z square plus 1. It is definitely satisfying this. So, what is the answer? Number of zeros क्या रहेगा? Here I am having 5, so it will be 5. Correct? So, number of zeros will be 5. Is that clear? That was quite easy if you put this thing. Now one more type of maybe next thing will be here. Again, determine the number of roots. Same thing, same question of this function 2z raised to 5 minus 6z square plus z plus 1 equal to 0. Find number of roots in this domain in annulus. That is 1 is less than mod z is less than 2. How will you do this? Do you have any idea how will you do this? What is this thing actually? If you draw, then it is a ring type structure. So ये 2 है, ये 1 है. So I am talking about all these things. Yes. How will you do? Any idea, anyone? I would like to find number of zeros. But by Roche's theorem, I know. How will you do? First of all, let me ask you. Yes. Rini, I cannot hear you. You were saying something? See, whenever you see something like this, so it is the best way to do one thing. You first calculate number of zeros in this domain, mod z less than 2. Correct? And the next thing you calculate all the zeros in this domain, mod z less than 1. Do you see मैंने क्या किया? I am just calculating all the zeros where it is 2, and then I am calculating all the zeros where the domain is 1. Actually थोड़ा सा छोटा बनाना चाहिए था ये. This is the trick I should use. So मेरा final answer क्या रहेगा? What is my domain? We are excluding this part ना. Mod z less than 1 नहीं है. I have to be inside this and mod z less than 1 नहीं. So I have to subtract number of zeros from here and number of zeros. Number of zeros this minus number of zero is this. So you have to calculate two things here. The first thing is find number of zero here. Second thing is find number of zero here. But in the question they were asking about this guy. Correct? So your final answer would be number of zero here minus number of zero here. Is that clear to you? So let us see for the first one. Mod z less than 2. Mod z less than 2. What is the function given? That is 2z raised to 5 minus 6z square plus z plus 1. Can you give me f of z and g of z? Such that mod f of z is greater than mod g of z. Can you give me? Again, I told you the trick. Mod f of z less than 2 है तो क्या करने का? Mod z less than 2, 2 से छोटा कोई भी नंबर पुट करो, 1.5 ये सब भी पुट कर सकते हो, but do not go less than 1 because in the next case we will be considering that. So it is better to take mod z equal to 2 ले लो, बाउंड्री पे ही चेक करते हैं. तो 2 पुट किया तो ये क्या आएगा? This will be 64 ना, 2 raised to, so this will be 64. ये क्या आएगा? 24 ना. This will be 2 and this will be 1. What should I choose my f of z? Can somebody tell me? What should I choose my f of z here? Correct, 2z raised to 5 of course. So it will be 2z raised to 5 if you take. Then what will you get? ये क्या रहेगा बाकी function? Minus 6z square plus z plus 1. Can I directly write the answer? Do you have to check this? You just do that. So number of zeros क्या आएगा इधर से? It will be 5, correct? Is that okay? The next thing I have to do in this domain, mod z less than 1 में, less than equal to 1 या बोलो less than 1 बोलो. So what is the function? 2z raised to 5 minus 6z square plus z plus 1. Can you tell me what should I choose my f of z and g of z? Again पुट करने का z equal to 1 पुट किया, ये आएगा 2, ये आएगा 6, ये आएगा 1, ये आएगा 1. Do you see? What should I choose my f of z? Quickly. Do you see that? What is my f of z? If you see, if you add these three people also, then also you are getting less than this 6. Correct? So better to take f of z as minus 6z square. Is that clear? And next thing will be 2z raised to 5 plus z plus 1. Is that okay too? Is it clear to you? So number of 0 will be 2. So what is the final answer? In the domain 1 is less than mod z is less than 2, ऐसा कुछ है. Number of 0 कितना रहेगा? It will be 5 minus 2 ना. It will be 5 minus 2, that is 3. So 3 is the final answer. मोस्ट ऑफ द टाइम स्टूडेंट्स क्या करते हैं, मिस्टेक क्या करते हैं वो लोग जस्ट ये फाइंड आउट करते हैं mod z लेस देन 2. हाँ 2 अपर बाउंड है तो ये कर लेने का, बट दैट इज़ रॉन्ग. यू हैव टू, बिकॉज 2 से लेस किया तो इट विल कवर दिस गाय ऑल्सो, बट आई डोंट वॉन्ट दैट गाय ना, सो आई हैव टू सब्ट्रैक्ट दैट. इज दैट ओके? Yeah, so that was the last part. Thank you so much everyone. So from here actually complex analysis का I have covered all the thing. If you go in masters also जो भी मतलब मैंने ट्रिक्स बताया और ये सब विल बी डूइंग जस्ट प्रूफ, इसका करोगे और कुछ नहीं रहेगा. And बाकी if you are preparing for an entrance exam or anything, you can give now, you can you don't have to study any extra, because I have covered all the things. और मतलब with my experience I can tell you कि what are the types of question you'll be getting and so on.